We're going to go over the procedure for the steam distillation lab. As I've mentioned, we'll be doing the semi-micro scale steam distillation, which is the first procedure that you come across in your lab book for this lab. You're going to weigh out your cloves. The lab book instructs that you should get about 5 grams worth of cloves. You'll want to grind them up using your mortar and pestle, and this is to increase the surface area of the cloves that can interact with water, which encourages the azeotrope of water and eugenol to form, and that's ultimately what we're distilling off today. You'll want to reweigh your powder to get a final mass of how much cloves you're going to be using for the lab. You'll place your cloves and water in the round bottom. And of course, the volume for water is listed in the lab book. You want to mix well. You want to make sure that the cloves are interacting with the water and intermingling. You will want to mark the solution height, and we'll talk more about that later. You're going to assemble the steam distillation apparatus, and if you need to know a little bit more about that distillation apparatus, if you didn't understand based on the lab book, then you can watch Travis's video that has been posted up in our Moodle lab class, and he kind of highlights the differences between the steam distillation apparatus versus simple and fractional distillation apparatuses that we've used already this semester. If you're trying to figure out what to do with your round bottom that has all these cloves and water in it while you're building the steam distillation apparatus, of course, you can kind of do this in whatever order you think works best for you. But if you've already got your round bottom filled with this kind of messy solution, pull out a cork ring from one of your shared drawers. If the cork ring is too tall or too large a hole, flip it over. Once you have it wrong side up, then that actually provides a smaller opening. And these 100 milliliter round bottoms that we're using as a pot, so to speak, for this week's lab should fit nicely in there. You're also going to be using a 50 milliliter round bottom as your receiving flask. Before you put that into your apparatus, you're going to want to measure out 30 milliliters of water and put it in that round bottom and mark that height with a Sharpie as well. We'll discuss why you want to mark 30 milliliters in just a moment on the next slide. You do want to pour that water out so that you have a completely empty round bottom as your receiving flask. You will want to go ahead and put water in your addition funnel. Some of the addition funnels in our lab have graduations, some of them do not. So you need to make sure that you keep up with what volume of water you have added into your distillation. Most of our addition funnels are not very large, so you probably can't put all 100 milliliters of water in as soon as you start the distillation, but you should keep up with it, and ultimately you'll probably need all 100 milliliters. It'll just have to get added in 2 different portions. So we have an image here of what the distillation apparatus looks like. Here's the separatory funnel. And of course, they're showing a separatory funnel. We will actually be using an addition funnel that is more conical. You saw a lot of these as you were searching for your separatory funnels a couple weeks ago for that separations lab. It does still have a stopcock, so make sure the stopcock is closed when you're adding in your 50 or 100 milliliters of water prior to starting the distillation. The Claisen adapter is kind of this U-shaped adapter. Notice we don't have a fractionating column in here. You just have kind of your traditional still head along with a condenser, the vacuum adapter that we've used in the past, and a 50 milliliter round bottom. The vacuum adapter has that side arm, so we are still allowing some kind of outlet to the atmosphere, so we don't have to worry about creating a bomb with this type of setup. You will be needing to use ket clips in all the appropriate places. And instead of using a Bunsen burner, as your lab book suggests, we're going to be using sand baths due to COVID. I don't want us having any open flames and cloth mask. So for your sand baths, if you have a large size sand bath, please use that. That's going to be the best way to go about doing that, and make sure to stir your sand if you have that capability. My suggestion for a setting for the sand bath would be 6 or 60%, depending upon what the readout is on your power adjuster. And of course, you can always scale up or scale down what your setting should be depending upon your distillation rate. The distillation rate we want for the steam distillation is 1 drop every 3 to 5 seconds. You're going to need to add water to the pot, and that's what your lab book refers to as the round bottom that has the clove and water mixture in it. You'll add the water every 10 minutes to keep the water level at its original height. That's why we're marking that original volume in the 100 milliliter round bottom with a Sharpie, so we can keep an eye on that level of solution. You're going to stop your distillation that you've done at 1 drop per 3 to 5 seconds when you collect about 30 milliliters of distillate. And again, if you remember, we marked the 30 milliliter position on that 50 ml round bottom so that you could accurately stop the distillation. You're going to want to let your receiving flask cool to room temperature. This shouldn't take super long. And then you will pour the distillate into a separatory funnel. And again, remember to use a ring stand and the appropriate clamps for your separatory funnel. So for the separation, you're going to add 10 milliliters of saturated sodium chloride solution to your distillate. And after that, you're going to rinse your condenser and receiving flask with dichloromethane. That's the solvent that I have abbreviated DCM here for dichloromethane. Once you have the organic in the separatory funnel with the aqueous solution, you'll extract the eugenol from your distillate into that organic layer. Think about where the aqueous layer should be. How dense is dichloromethane? That's one of those pieces of information you can look up prior to coming to lab. Dichloromethane is a very dense solvent. So in fact, this time for separations, your organic layer is going to be the bottom layer. In a lot of ways, this makes doing extractions and washings pretty easily. You're going to collect the organic layer. You do not want to collect any aqueous layer in with this organic layer. You will, once again, rinse the condenser with dichloromethane along with that receiving flask again, and repeat the extraction of the organic layer, trying to pull all of the eugenol that was in the distillate into that dichloromethane. You will repeat this rinsing and extraction one more time. Of course, after each extraction, you want to separate off the organic layer, and all dichloromethane layers can be combined into one Erlenmeyer flask. So just make sure you're doing your separations according to the protocols that we familiarized ourselves with a couple weeks ago. Even if I don't have all the details here, your lab book does have all the details. You're going to dry your organic layer with sodium sulfate. Once again, we've used that in the past. Remember to cover the Erlenmeyer flask with parafilm. The lab says to use a stopper, but we don't really want to use black rubber stoppers with these organic solvents. It will actually chew away at the black rubber stoppers. Do not be surprised if your parafilm kind of bubbles up. Dichloromethane is quite volatile, so you will have some of that going into the vapor phase while it's sitting. And dichloromethane definitely has a distinctive smell. It smells quite sweet. So covering it up cuts down on how much you're smelling from it. You want to allow your organic layer to dry for about 5 minutes. Remember, drying just means removing water. It doesn't mean no liquid. Okay. You're going to weigh a clean, dry 50 milliliter round bottom and record its mass. And then you're going to use a pasteur pipette to transfer the dried dichloromethane to that flask. Okay. You do not want to transfer any of the sodium sulfate to it. So be careful that you don't accidentally pipe up any granules of sodium sulfate. It will be very obvious at the end if you have transferred sodium sulfate over. We should collect an oil at the end. It's clove oil distillation after all. It will be obvious if you have a solid in that round bottom. You do have a rinsing step for the drying reagent in this lab. So you're going to rinse the sodium sulfate 3 times, each time with 2 milliliters of dichloromethane. And those rinses should also be pipetted into the round bottom. We're not decanting for this lab. We are actually being very careful and trying to pipette our material over into a round bottom. We will not be doing a simple distillation. Instead, we will be using a new piece of equipment called a rotary evaporator.